We had 2 questions for homework on last night on page 47. I'll remind you that these both involve acceleration. Therefore, we use what we call Group B equations. Remember that Group A equation? We learned it on the very first day of Physics 20. V is equal to delta D over delta T. That's the one, the Group A equation, that is not valid for this. That's valid when we have constant or average velocity. And both of these questions involve acceleration. Therefore, we have to go to our Group B equations. Our Group B equations, we had 5 of them. We had A is equal to delta V over delta T. We had D is equal to VIT plus 1/2 AT squared. We had D is equal to VFT, almost the same as what we just wrote down, VFT minus 1/2 AT squared. We had VF squared is equal to VI squared plus 2AD. And we had D is equal to VI plus VF over 2 times T. So now, whenever we have a problem involving acceleration, like we do here, both of these problems on page 47, we use one of these equations, our Group B equations. That's the first thing that you want to do now every time you read a question. Is it Group A? Is it Group B? Does it involve constant or average velocity, or does it involve acceleration? If it involves acceleration, then you're going to use Group B. All right, let's take a look at question number 1 here. It says a motorcycle with an initial velocity of 6 meters per second to the east accelerates at 4 meters per second squared to the east. How long does it take the motorcycle to reach a final velocity of 36 meters per second to the east? This is accelerating, right? This motorcycle is speeding up. It's accelerating. Therefore, we've got to use our Group B equations, our green equations right here, or at least one of them. Which one? I don't know right now. Like off the top of my head, I don't know any more than you do right now as to which equation I'm going to use, beyond that it's Group B. So this is when, after we've identified that it's Group B, that we write down our givens and we try to see which one fits the best. We said yesterday the worst case scenario is that we pick a Group B equation that doesn't work. It won't give us the wrong answer. It just doesn't work sometimes. So then we pick another one. That's all. Let's write down our givens here for question number 1. We're going to say VI is 6.0 meters per second. We'll say east is positive. Right? East is positive. VI is 6 meters per second. We're going to say it accelerates at 4 meters per second squared. So it's not saying that that's how fast it goes, 4. It's saying that's how quickly it accelerates, so how quickly it speeds up. What are we looking for there? How long will it take the motorcycle? What variable is that? Yep, that's time. We're looking for the time. How long, how much time does it take the motorcycle to reach a final velocity of 36 meters per second? We're going to say VF is equal to 36 meters per second. Agree? Okay, which one do you want to try? Yeah, Jacob?
A equals V over T.
Yeah, that's probably the one that I would use as well. A is equal to delta V over delta T. What are we solving for? Time. Let's go back to the method that we learned for rearranging equations. Time. It's on the bottom. What do we got to do? Like, we have our 3 rules, right? Get rid of what's not attached, get rid of what is attached, and then get rid of squares and square roots. But before we do our rules, we've got to get it to the top. How do we get that to the top? How do we get T to the top here? Multiply. It's divided, so let's multiply. Let's say delta A times delta T is equal to delta V. Now, we're still looking for delta T, but now we can follow our rules. First rule, get rid of what's not attached. What's not attached to T? Nothing. Everything's attached. Okay, what is attached? A. So let's divide by A, because it's multiplied by T. So T becomes equal to delta V over A. Delta V is VF minus VI, final minus initial velocity. 36 minus 6 meters per second over A is 4.0. So 36 minus 6 is 30, divided by 4.0 gives me 7.5. And the units we use for that are seconds, because now that we're in Group B, acceleration, we always use those standard units. Meters, seconds, meters per second squared, so on. Okay? Let's try number 2. 2 says, an elk moving at a velocity of 20 kilometers per hour north accelerates at 1.5 meters per second squared north for 9.3 seconds until it reaches its maximum velocity. What is the maximum velocity? I said yesterday, I don't really need it in kilometers per hour. You give it to me in meters per second, that's fine. I'm going to erase this so we have some space to work here. An elk moving at 20 kilometers per hour. What is that 20 kilometers per hour thing? By the way, north is positive. Tell me what that is. Is that V? Is that VI? Is that VF? Is that A? Is that T? What's the 20 kilometers per hour? What is it? VI. It's the initial velocity. That's how fast the elk is moving when it starts accelerating. VI is 20 kilometers per hour. It accelerates at 1.5 meters per second squared. What is that? Is that A? Is that VF? Is that T? What is that? It's A. That's the acceleration, right? It accelerates at that. Meters per second squared. There's your little clue on that. Meters per second would be velocity. Meters per second squared is acceleration. Reaches maximum velocity. 9.3 seconds. That's time, right? What's the maximum velocity? What are we looking for here for the maximum velocity? VF. Okay, before we solve for VF here, before we worry about like which equation we're going to use here, let's convert kilometers per hour to meters per second, all right? All right, let's just get rid of that kilometers per hour, get into meters per second right away. That's the same as 20,000 meters. Okay, we multiply by 1,000 to get meters, and then on the bottom, 1 hour is the same as 3,600 seconds. I think it works out to be 5.55, isn't it? 5.555? 6 meters per second. All right, which equation do you want to try here? Which one looks like it fits the best? None of them. It may be that none of them are perfect. Which one looks like it fits the best? Cameron? A equals delta V over delta T. Okay, maybe that works. Maybe it doesn't. Let's try it. Okay, A, I got it. I got A. T, I've got it. So the only thing I don't have here is delta V. I'm not looking for delta V. I'm looking for VF, but I got VI. So isn't that pretty much the same thing? I have VI. I want VF. Delta V. Okay, let's do that. Let's solve for delta V here. Yeah?
Can't you split it up into VF minus the number that you have, 20 kilometers per hour, and then just solve for VF of that?
Could you repeat that?
So instead of delta V, which is the change,
Yep.
you put in VF, which you don't know, minus 5.5 repeating.
Into this equation, you mean? Okay, you know what? Let's do that. Okay, we could rearrange solve for delta V and then get VF, but let's just put VF minus VI right into the equation. Okay, you can do it either way. It becomes a little bit harder to rearrange that way. That's all. Okay. Actually, you know what? Let's not. Okay. The reason I'm not going to do that right now is because it requires one of those other little notes at the bottom of the page that I gave you for rearranging. And I don't want to overwhelm you with rearranging right now. Okay? Remind me tomorrow, and I'll show you how to sub that in there and rearrange it with the other little note. Okay? So let's solve for delta V. Get rid of what's not attached. There's nothing not attached. Okay, get rid of what is attached. What is attached to the delta V? Delta T. How do you get rid of it? We've divided by T, so I take it over to the other side by multiplying. So I say A times T is equal to delta V. Or you could have written it as delta V is equal to A times T, right? Delta V is A, 1.5, times T is 9.3. When I multiply those two numbers together, 1.5 times 9.3 I get 13.95. Okay, so there's delta V, my change in velocity. But remember, that's equal to VF minus VI. What do I want to solve for now? VF. So get rid of what's not attached. What's not attached to VF? VI. How do I take it over? Adding. It's subtracted, so take it over by adding. And I get delta V plus VI equals VF. Or VF is equal to delta V, which I already know what that is. It's 5.555 plus, no, sorry, delta V is 13.95 plus the initial velocity, which is 5.556. And I get 19.5 meters per second. We won't worry about converting that to kilometers per hour right now. Make sense? Is that okay?
Hey, that's fine.
Good. You sound surprised there, though.
No, because when you started talking at first, I thought I did something wrong.
No, I just didn't want to. I just didn't want to go into the rearranging of that right now because I introduced you to the algebra involved, and we got to the point where we could do most things, but not all. And I didn't want to go any further with that today. So I just say tomorrow, remind me of that, and I'll go to that next step tomorrow. But one day at a time here. Yep. Yeah, go ahead. All right. Let's take a look at another example. This example is on page 48 of your textbook. This question says, a cattle train traveling west at 16 is brought to rest in 8 seconds. What's the displacement, or find the displacement of the cattle train while it's coming to a stop? So during the time that it takes the cattle train to stop, how far does it travel? What's its displacement? Is this group A or group B? Group A? This is constant or average velocity. This cattle train is moving at 16, and then it's stopped. In order to stop, it must slow down or decelerate, right? That's group B, isn't it? When it involves acceleration, deceleration, acceleration, that's a group B problem. This is definitely group B. Okay, now let's write down our givens. What do we have here? 16 meters per second is what? That's VI. That's how fast it's moving at the beginning of this problem. VI is 16. What else we got? T, somebody said? T is 8.0 seconds. Okay, I heard somebody say VF. Who said that? Okay, VF is, William? Good, VF is 0. It's brought to rest. Rest means stopped, right? So it starts at 16, and then it's stopped. It starts at 16, and then it's brought to rest. So we're going to say VF is equal to, 0 meters per second. We want to find the displacement. We want to find delta D. Remember your group B equations. Those group B equations all on your data sheet or on the right side of this page. Which one looks like it fits? Which one looks like it fits the best? I say that with a little caveat. And that little caveat is, you know what, it doesn't really matter. If you pick the best one right off the top, that's great. It'll save you a little bit of time. But if you don't, that's okay. You're not going to get the wrong answer. The worst that's going to happen is you don't get an answer. But that's okay, because that's like saying you got a multiple choice question, and the options are 1, 2, 3, 4, and you got 17. Well, you know you just got to try again, right? If you don't get an answer, try again. Okay, William, what do we want to try?
Delta D equals VI plus VF divided to multiplied by time.
Yeah, I think that's what I would do as well. VI plus VF over 2 times T. It looks like it fits perfectly, right? Let's try it. If we're wrong, if you and I are wrong on this, it's not a big deal. We're not going to get the wrong answer. D is equal to VI plus VF over 2 times T. Do I have VI? Yes. Do I have VF? Yes. Do I have T? All right, it's going to work then. VI is 16 plus VF is 0 over 2 times the time of 8.0 seconds. We're kind of lucky on this because we don't even have to rearrange it, right? Let's do this on our calculators, though, to make sure that you guys can do it here. 16 plus 0, of course, is 16. Divide that by 2. So inside the brackets, I've got 8. And then I multiply it by 8. And I end up with 64. If I get an answer, and assuming I haven't made some silly mistake somewhere, then it's got to be right. So William suggested that I use that equation. Hey, that is the most efficient one. Let's say, though, let's say that he didn't try that one. Let's say that he had to try this one. Let's say that he had to try D is equal to VFT minus 1/2 A T squared. Let's say you had to pick that one. Is that okay to pick? Yes, it's group B. Do I know what VF is? Yes. Do I know what T is? Yes. T? Yes. A? So what's the problem with this one? 2 unknowns. I can't solve it, right? That's okay. If William had to pick that one first, then he just would have picked another one, right? Got it? I'd like you to take a look at these 2 questions now on page 48. Remember, you've got to identify whether each of these is group A or group B. And then once you do that, remember, you've got to write down givens. And then once you've done that, remember, you've got to write down an equation. Don't skip steps. Okay, you're not smart enough for that. Guess what? Neither am I. We all have to do the same thing. Okay, we all have to go through the steps. Write down the equation, write down the givens, identify is it group A or is it group B. We all have to do that. Don't try to skip steps because you're going to mess up. All right, we're going to do number 2 here. It says a ball moves up a hill with an initial velocity of 3. 4 seconds later, it's moving down the hill at 9. Find the displacement of the ball from the initial point of release. So let's visualize this. Here's the hill. The ball is moving up the hill. And what happens to it? As it goes up the hill, the ball will slow down and stop, and then change direction and speed up. We want to find the displacement during the time that it took to go from 3 up the hill to 9 meters per second down the hill. Is that a group A or group B problem? That's group B. It's definitely accelerating, right? Or decelerating, speeding up or slowing down, or both, actually. So we know it's a group B problem, that we know that we can use those 5 equations that we learned yesterday. These ones. Well, let's write down our givens and then see which of those 5 equations seem to fit the best. What is this 3 meters per second thing? That's going to be what? VI, yeah. VI is 3 meters per second, good. What is this 9 meters per second thing? What is that? That's VF. Good. We don't have anything else, do we? Oh, we have time. Time. That's right, 4 seconds. T is 4.0 seconds, 4 seconds, and we're looking for the displacement, right? Now, before you pick an equation for this, Barker's got it, eh? What is it? Okay, never mind. Yeah, go ahead. Before we go any further with this, before we pick an equation, Who thinks they can find the mistake that we made? It's just a small one. Rachel, what is it? Yes. The final velocity is 9.0 meters per second down the hill, right? So it's negative. Got it? We're going up the hill is positive, down the hill is negative. Really, we should have defined that. Up the hill is positive, and therefore we would know down the hill is negative. That's important. Okay, if you miss that negative sign, then you're going to get this question wrong. All right, which of my group B equations looks like it fits here? The best, that is. They're all valid. But which one looks like it fits the best? Demi, which one do you want to try there? The bottom one, VI plus VF? Yeah. Okay, that's the one that I would pick as well. Demi, I think that we've got the right one here. But if we don't, then we'll just try again, right? VI is 3. VF is negative 9 over 2 times a time of 4 seconds. Okay, that's going to work. 3 plus negative 9 is neg 6. Divided by 2 is neg 3. Neg 3 times 4 is neg 12 meters. What does that negative mean? Yeah, we ended up 12 meters down from where we started. You could say negative 12, or you could say 12 down. Either one of those would be correct. It wouldn't be correct to say negative 12 down, right? Okay, let's do one more example, and then we'll leave it there for today. This one's on page 50. This one says a golf ball that's initially traveling at 25 hits a sand trap and slows down with an acceleration of negative 20. A negative acceleration means slowing down. Find its displacement after 2 seconds. Is this a group A or group B? That's what we've done every time first, right, is identify group A or group B, even before we look at our givens. Okay, you're right, it is a group B equation. So knowing that it's a group B equation, we know that we're going to use one of these 5 equations. Let's write down our givens, and then we'll decide which one of these 5 that we use. Something's 25 meters per second. What is that? That's VI. The ball was initially traveling at 25. It's a sand trap that slows down with an acceleration of negative 20. What's that? That's the acceleration. 2 seconds, what's that? That's my time interval. And what are we looking for? The displacement. We're looking for delta D. All right, all 5 are valid. Which one do you want to try? Tim, which one looks like it might work here the best? A is equal to delta V over delta T? VIT plus 1 half AT squared? Okay, let's give that a try. By the way, I thought, Tim, that you meant this one. Okay, I was going to write that one down because it's not wrong. I do think that you would have found, you wouldn't have been able to solve for the answer using that one. Okay, this is a more efficient one for sure. That's okay. VI, we know, it's 25. T is 2. A is negative 20 times 2 squared. Follow along with me on the calculator. In fact, do it along with me on the calculator. Take your calculators out and do this with me. 25 times 2 gives me 50. I can write that down. Don't try to skip steps. Just do it in small steps. Then let's say 0.5 half times negative 20 times 2 squared. That gives me negative 40. 50 plus negative 40 gives me 10, positive 10. How far does it travel in that 2 seconds? 10 meters. All right, your homework tonight, and you can work on this for the next 5 minutes before the blessing comes on. Page 50, questions 1 and 2, please.